start now. So, hey everyone, thank you very much for coming out to our presentation. It means a lot to us. So today, we're going to be talking about building a scouting application that learns. So we'll start by introducing ourselves. My name's Connor. I'm a senior in high school. I've been part of Team Paradox 2102 for 4 years now, since I was just a little freshman. And I am one of our all-team co-presidents and also the scouting lead.
My name is Wade. I am also a senior, and I've been on the team for 4 years. I'm the engineering president, drive coach, and also lead designer. And I'm going to be going over the deep learning with PyTorch and FastAI in a bit.
And I'm Blake. I'm a sophomore in high school. I've been on the team for 2 years, and I'm a programmer and a driver.
So, a bit of an introduction to start with. The question has long been asked, is scouting relevant to FIRST Robotics whatsoever? So the question has been asked by mentors, students, parents, teachers alike, even some of the previous scouting leads on our team, or even people who put straw polls on Reddit to find an answer. However, my answer has always been that yes, scouting is relevant. However, you just simply need to make it relevant. So we're going to take it back all the way to about 2015. When I was at my very first robotics competition at the Central Valley Regional in Madera. I go up in the stands and I see people frantically scribbling away on sheets of paper, and I'm like, what are you guys doing? And they're like, oh, we're doing scouting. We like log the performance of other teams during the competition. And I'm like, oh, that's pretty cool. So at that point, we were doing paper scouting, which is something that you see traditionally done a lot at competitions. However, I noticed a lot of problems with paper scouting on our team, and also so did a lot of other people. Some of the main problems were that paper scouting was very slow, it was inefficient, there was no way for a big group of people to look at the data and analyze it together. There was no way to sort it, and basically you have to work all these freshmen during the competition and have them frantically scribble down data for 6 hours a day for 2 days. And then that data was essentially wasted because there was no good way to actually look at it. So that's what inspired us to actually develop a scouting application, something that was easy to use, intuitive, accessible to everyone, something where the data was actually able to be looked at in a meaningful way. So, ever since the development of that application, we've seen a lot more success on our team, especially in terms of scouting. It's a lot easier for us to adequately assess the performance of teams that we're competing against at competitions. So, and from that point on, RoboRecon, also known as Paradox Scout, was born. So, I'm going to give you guys a quick little tour of what exactly we came up with to solve these problems. So, this is what our scouting application actually looks like. Oh, actually, I should go on the home screen first. Okay, perfect. So this is what our scouting application actually looks like. So we found that the easiest way to sort all of this data that we collect would be in a spreadsheet format. So on the homepage of our scouting application, this is all data that's pulled from the Blue Alliance. This is all data that's publicly accessible. And since it's in a spreadsheet format, you can just easily sort all these columns. But the thing is, Blue Alliance data isn't exactly what we're looking for, because Blue Alliance data is data that's specific to the entire alliance's performance in a given match, but we want team-specific performance. So how exactly we do that is we came up with a system that would list out every single match at a competition, and then it would put each team into a column like this. So how exactly we do scouting on our team is I would assign one person, usually a freshman, to follow along with one column on this page. So for example, side note, this is all data from the Idaho regional that we were at last month, just so no one gets confused. So how we would go about doing this is one scouter would look at a column right here. Let's say we're on qualification match 1, and they would just simply click this little rate team button. And that would bring them to our team rating page. Oh, let me scroll down a bit so you guys can see everything. That would bring them to our team rating page, and it automatically selects exactly what team they're looking at. So this is extremely customizable, and we've actually customized it between regional events even. So we found that this is all the data that we would find useful to look at for a specific team during a competition. So we have it split up into two separate parts. We have autonomous right here. Actually, I'll use this. We have autonomous on this side and the teleoperated section on this side. And how we managed to, the best way we found to accumulate all of this data for this year was during autonomous and teleoperated, we would split the cubes up to the amount that they would make in the scale and also the amount that they would attempt to make but unfortunately miss. And also we would be able to rate their efficiency. Because if they make 2 cubes in and it takes them like 10 seconds to do it, that is extremely efficient. Let's give them a 5. However, if they make 2 cubes in but it takes them the entire match to do it, I mean, good job, but probably could have been more efficient. So that's when you'd give them a lower rating. Also, not trying to say anything about that team. I love them. They just happen to be the one that I selected. So, additionally, yeah, things like crossing the baseline, you could select things like that. And also, we have efficiency ratings for everything during teleoperated. And additionally, the amount of cubes put through the exchange. And also, we have ratings for climbing down here, whether or not they're able to park at the bottom of the scale, climb at the end. And if they are able to climb, what if they have like 2 platforms that come out and carry other robots? Well, then you would say that they carried 2 robots with them. And additionally, well, finally, we have the robot stability rating down there. So after one person would fill out a scouting report, they would just simply click submit over here and it would submit it. And this looks really nice. Well, in my opinion, it looks really nice. It looks really nice on a laptop. However, no one wants to bring around like a laptop. Well, I mean, some people do, like me. But not a lot of people want to bring around a laptop with them at competitions. And this is a great solution for that because this also works extremely well on your mobile devices, on your iPads, on your Nexus tablets, maybe a Kindle. We haven't tested that yet. But yeah, it works great on everything. And it's very intuitive, simple to use. People who have like never even like seen the competition before, like parents who I sometimes get, or like mentors who are like new to the team who don't exactly know what the game is about. It takes me like maybe a minute max to explain to them how exactly to go about inputting data for a specific team. So yeah, this is just our version, what we found most useful for this year's game. But again, this could also be wildly customized if we found something else that we wanted to add between regional events. Like for example, last year at our first regional event, we realized afterwards that sometimes the pilots in the airship wouldn't exactly be like, you know, extremely skilled. So we put in a rating for pilot competency, where like, you know, if they like dropped a gear out, you'd be like, oof, sorry, knocking you down to a 4. And yeah, no, that actually proved to be very useful because then we could like adequately assess what pilots we should have in the airship if we had a match with the team. So now, onto the team details page. This is a page where we get really nice looking graphs. Look at these. Oh, so we get really nice looking graphs that are based on the data that both the Blue Alliance gives us for teams and also that our scouting reports give us for teams. So this is all scoring trend analysis that the Blue Alliance gives us for a given team during a regional. And as you can see, it goes from like qualification match 6, 13, so you can see exactly what match it was looking at. And you can actually select which data points you want to look at, or, oh wait, I can't see what's going on there. Oh, I can zoom in, great. Oh, I zoomed in too much. Oh, I can reset it. It's perfect. And I mean, actually, it's a little bit excessive, but you know, it looks great. So now this is the data that our scouters individually collect on a team. So for example, this would be like average cubes put on scale. Yeah, this is just in like bar graph format for the sake of simplicity. But yeah, you could also look at things here. And yeah, you can also view data up here for like the match played, also their OPR. But this is also stuff that you could view on the main screen, so not that important up there. So going here, we found out that sometimes people make mistakes. Our scouters would sometimes accidentally mix up the switch and the scale together. You know, it was kind of tragic. However, what we are able to do here is we're able to look at the scouting reports that each individual has put in. So I can see here that 18 days ago, Steven put in a report for team 1566. And if he made an error, like if I see that he accidentally said that like, oh, they put like 90 cubes on the scale or something, I could be like, Steven, get it together. Well, I'd be more nice about it. But if anyone's making errors, then you could always go in here, look at it, and correct it. So a new feature that we added this year is pit scouting. So pit scouting, personally on our team, we have mixed opinions about pit scouting because a team can really tell you anything they want about their robot when you're asking them about it in the pit. So we decided to ask them just simple questions. What's your drivetrain? What's your drive orientation? What's the weight of your robot? How tall is it? Because how are you really going to lie about those things? And also during autonomous, what exactly they can do. So the reason that we don't exactly prioritize pit scouting is because a team could tell you anything. They could be like, oh, we can put 20 cubes on the scale. And then during the regional, if you were using our application, you could go back and say, I'll be the judge of that. I'll go look at your team's data on our scouting application.
I was going to say really quickly, one reason why we also added pit scouting this year was, we were actually originally planning on adding or having a triple climb capability for our robots. So like weight and like height was like really important for like getting that to work. And also this year, at least for autonomous, just with like how everything is lined up on the field, it's like really important to like know like before, all of your matches where everyone like lines up for their autonomous modes. So that was really useful this year, whereas last year wasn't as critical, I guess. So, yeah.
Yeah. All right, now, also the pit scouting page. This could also be customized to however detailed you want. If you're very trustworthy of what teams tell you in the pit, you could just put like everything in there, but we just kept it simple. So this is where the application becomes very valuable. So this is our scouting dashboard page, and this is a spreadsheet formatted layout of all the data that individual scouters put in for robots during a match. So again, this is all sortable. If I wanted to figure out what team put the most cubes on average onto the switch during teleop, I could just sort it like that. Oh, congratulations, 2594, you get a bit of street cred. And then the scale during teleop, 2130, oh, sick. Exchange, 66, okay, that's pretty good actually. So yeah, this is personally, especially during alliance selections, one of the most useful pages in the application, because this isn't the blue alliance data like data that's collected for the whole alliance and then kind of just like thrown onto one robot. That's not exactly accurate. This is specific to one robot during a given match. So then your data is extremely specific, extremely accurate, and you don't have to worry about like potentially like a team getting just really good matchups with like two like IFI teams like every single match, and then they look a lot better on the blue alliance data, because this will give you the honest, the truthful, actual results. So another feature of our application that we added, this is personally one of my favorites. We have our match intel screen. It takes a second to load. So based on all of the scouting data that's collected over time, wow, this is actually really big, okay. Hopefully you guys can still read that, kinda. I don't know, I'll point to things. Okay, so this gives data on every single team that's playing in a given match. So these were all the teams that were playing on the blue alliance during this match. As you can see up here, their OPR is listed, their calculated contribution to the winning margin is listed. Also, it shows data that we collected from that team for pit scouting. So this all up here, all of this up here is blue alliance data. Not the most useful thing, but why not throw it in? What is really useful down here is the scouting data that's collected. So we can see that this robot has an average stability rating from 1 to 5 of about 2.5. Maybe they had a couple matches where they broke down, maybe something fell off the robot. I don't know, not completely stable though. And also, if we look at their average cubes they put on switch during teleop, 4.9, and we can look at their accuracy of that's accumulated over the entire regional. So they have 87.5% accuracy, which is fire, actually. And also, this team down here, 100% accuracy, perfect. And additionally, we have listed down here strengths and weaknesses of the robot. So we can see that down here, their mobility percent, like the amount of times that they're able to successfully cross the baseline during autonomous is 80%. That's a strength. However, we can also look at their weaknesses down here. See the average amount of cubes that they put into the exchange during a match, a bit low, 0.30. So they're not exactly an exchange bot. And this is all things that you can look at. This gets better and better as more scouting data is put into the application. So if we know that we're going to be playing Quals 80 or like even like a quarterfinal match, we can just click on that match at the scouting application and get intel on the teams that we're playing against. This is especially useful during something like Stronghold back in 2016, right? Yeah, 2016. Because we could see what obstacles teams were able to go over the easiest. So we could see that a team, oh, they cannot do moat. Then we would go and select our defenses and say, hey, we want moat, because we can see that this team can't do it. So that was especially useful there.
I was going to say also really quickly, this page is like really useful for showing other alliance members basically how they stack up against the opposing alliance and vice versa, like before matches. So it's really nice for just the pre-match planning, I guess, with other teams, not just by, I guess, subjectively like stating off how you think the other opposing alliance like will perform against you, but actually showing them like the raw data and like, I guess, factual evidence that like this is how this match probably is going to end up with this screen. So it's super helpful for that on that front.
So yeah, that's pretty much a basic run through the application. If you're looking at this and you say, okay, I want that. Well, oh, I zoomed in way too much. Okay, we'll keep it there. If you're looking at this and saying, I want that, well, it's actually pretty easy to get your hands on it. So you could just go to, was there a question? Or, oh, never mind. Okay. So you can just go to our website, team2102.org, and under the resources tab right here, we have our scouting page, which will get you here. That'll give you some more information regarding the application, some features that I kind of already went over. Oh my, okay. We have pop-ups on our website.
Not our choice, not our choice.
I didn't do that.
Yeah.
So if you want to set up the application for yourself, then we have instructions listed right here, and this would link you to our GitHub repository. Even if you've never done something like this before, even if you have only like basic experience, we've tested it out. It's actually not too hard to get it completely set up. And if you run into difficulties, you could always just email someone like me, and I'll get you walked through it and make sure that, oh my gosh, and make sure that you get it set up. And also, if you're a nerd, then you can go on our GitHub repository and look at oh, I was trying to zoom out. Okay, we'll keep it like that. You can look at the code for our application. If you want to just like look at ours as a baseline and kind of develop your own version of the application off of that. So yeah, if you're interested at all in looking through that, I highly recommend you to go there. If you're interested in setting up your own version of the application, head over to our website. There will be a link at the end of our presentation. However, why did it go back? Oh, no, it didn't go back. Okay, we're good. So, okay, I'm going to try to speed it up here. A couple quick examples of how exactly we use the application. A question that we had to ask ourselves during the qualification and playoff matches at the San Diego Regional earlier this year, what should we focus on during matches? And then the answer was the scale. So why? Because it became incredibly apparent to us through the data that we had collected throughout the regional that scale ownership, especially during autonomous, was a major deciding factor during the match. And also, this is one of the best examples I can give, alliance selection during the San Diego Regional in 2017. So we were the second place alliance, and the question was, who do we pick? And then the answer, the 14th and 15th ranked teams. Needless to say, people in the stands were pissed. They were like, what are you guys doing? What are you thinking? 14th and 15th? Why didn't you pick like 4th and 5th? Well, the truth is that our data, and data doesn't lie, our data said that the teams ranked 14th and 15th were the best gearbots that we could have chosen at that competition. And remember, that was steam-powered. Steamworks.
Yeah.
Oh my gosh, I'm sorry. That was Steamworks, and that was during that competition. Yeah, we found out that getting gears up into the airship, putting them on, rotating them, getting those rotors to spin, that was the most important factor in winning a match. And also, the data revealed that those teams were also able to climb at the end of the match. So yeah, those are just a couple quick examples of how exactly we use that data. And yeah, if that sounds appealing to you, then you know you can get some of those uses out of the application yourself just by signing up for it.
So what are the results of those picks?
We won the regional. Forgot to mention that. Yeah, that was a really happy moment because it seemed like those picks were like really like unapparent at first, like unappealing, but you know it worked out in our favor. So now I'm going to pass it off to Blake Lieber, and he's going to talk to you about the framework of the application.
Okay, so yeah, I'm going to talk about pretty much the code behind the application that Connor was just describing. So here our actual application, like what we use. So we use Jekyll. It's pretty much like the underlying app that we use. So it's what it's how our application runs locally. So when we're doing development, and also for everyone to use. We use Firebase. So it's our NoSQL database. It's real time. So if somebody like Wade over there updated something on his phone, it would instantly update on my computer without actually having to refresh the page. That's something that's really helpful when you want to get the latest information. We use JavaScript. That's the main language for the actual underlying scripts that are running behind the application. And we use HTML. That's how like the pages. That's how we format the pages. We do OAuth. That's authentication for Google and GitHub. So that's how we have everyone sign in. We don't actually create a username and password. You just use your Google account. GitHub is our version control, and it's also where we host our website. It's called Github Pages, which we talk about a little bit later. And then we use Docker. It's the development environment. So that's one way. If you have Windows Pro or if you have a Mac, you can use Docker. But we found other ways to actually get around that. So some of the pros to this is that it's free and it's easy to deploy. And it's actually a lot of fun to overcome the challenges that we have working with like a NoSQL database, and it's real time and things like that. Some cons is that it's no server side, so pretty much everything you see on our scouting application, it's always loading on your phone. It's not actually hosted. I mean, it's hosted, but the data isn't stored somewhere. It's constantly being updated on your device. Developers with Windows machines, if you didn't have Windows Pro, it was kind of hard to actually start getting development, but we found a way around this. You kind of dual boot with Ubuntu, I can't pronounce that, but
Almost. Yeah.
what?
That's all right. Yeah.
So that's how we were able to get around that. So like I don't have Windows 10 Pro in my laptop, but it was actually easy to start developing once we figured that out. So the beauty and pains of Jekyll. So again, that's like the underlying what we use for our application. So the pros, you can actually use GitHub Pages, which is again where we're hosting our application for free. And the site links and layouts are actually extremely easy. Once you create your HTML page, you can choose what the link you want that HTML page to be. Some cons is that it's a static website. Everything has to be in JavaScript, which can cause issues because JavaScript is asynchronous. So meaning it runs one line of code, and then it runs the next one without actually waiting. So that can cause a lot of issues. And then updating stuff live can be an issue. So with Firebase, having your application constantly reloading can sometimes cause issues. So beauty and pains of Firebase, which is the database we use. So some pros. Easy authentication. It has built-in authentication for Google, GitHub, Twitter, Facebook, email, username, and password, so anything you want to implement. And data access is actually extremely simple. You just have to know the base URL and how you have your data organized, which is easy to see on the Firebase website. Some cons, there are security rules, and updating data is somewhat confusing. So that's a part of Firebase. It's kind of hard to understand, like, what rules does this one page have versus another. Everything has to be loaded in over JavaScript, which again causes issues with the asynchronous, but we found an easy solution on like one of the next slides. It's mildly demanding on our browser. So again, like currently having to update your phone every time someone makes an update on one device, it's constantly updating on yours. Yeah. So then Firebase and Promises. So this is what I was talking about with Node.js being asynchronous. So it doesn't wait for one function call to be over before it starts the next one. So promises allow Node to run in a synchronous fashion when calling Firebase or any place you're trying to get information. So let's say one line of code, you're trying to get the user who's currently logged in. Well, Node.js would normally just run the next line, and you actually won't have the user's information yet, so it'll crash your entire crash the application. But promises using .then or .next, it forces the application to wait, and it's pretty much Firebase making a promise saying, once I have this data stored for you, I will run this next line of code, and I will continue to run until, like this code, and it'll keep going down until you tell it to stop. So then class organization, I'll actually show you the files later on. I'm just gonna get through these slides. So the class organization, our JavaScript classes are stored or organized by their uses. So there's a Firebase class, which pretty much it just is used to communicate with Firebase, getting the users, getting the teams, getting scouting reports. And there's also the Blue Alliance JavaScript class, which is getting the Blue Alliance data that Connor showed you earlier. So we store these functions in a very easy to access global variable that we call later on, that we use in our main app file, but we also can use it anywhere else inside of our HTML pages, so it's really easy to use. And then we have a config file to easily transition between each year, so that like last 2017, so Steamworks, we had gears and the number of the fuel shot into the boiler. So, but that has nothing to do with this year. So pretty much what we did is we copied that file and we pasted it over, except then we renamed everything. And everything that's used pretty much more than once is stored in this file, so then it's easy to transition between year and year. So you don't have to go into every single page, find the one time you use the multiple times you use the variable and change the name. And so GitHub Pages, this is what I was talking about. It's our free hosting service that GitHub allows if you're using like a Jekyll or a static website. So pretty much GitHub worries about keeping it like running or live for other people to use, and we just worry about deploying code and keeping up with the development. So now I'm actually gonna go over the code that we used. So right here, this is our API services. So this is communicating with the Blue Alliance. So like pretty much as you can see here, we have all these functions. So like get events, get event, so the current event. And what we're using here is that we use this these base variables up here. So dash API, dash version 3, that's the current version they are on their API, the Blue Alliance. Dash events, or depending on what you're actually trying to get, dash years. So this will give you the entire list of the years, of the entire list of the events according to the year, or you can actually get a specific event. So if you go to the Blue Alliance, they have very nice API documentation. So that's how we were easily able to get this information. So we have all the functions relating to the Blue Alliance here, and we don't actually have any other functions for the Blue Alliance anywhere else because we want it to be easy access and easy to change later on. And this is where we actually like return it. So these are the functions that get stored to that global variable. So we can use later on. So we actually use that here, like team data. So Paradox Scout is the global variable we created. So I don't know if you guys can see that, but yeah, right there. So on team scored added, that's something I'll show you guys later on. It's so pretty much, yeah, we just call Paradox Scout, and that's our global variable for us to easily access anywhere in our application. Data services is the talking to Firebase. So this is where the promises come in. So here you can see like we have this weird thing .then, which doesn't seem like a normal thing to have, but what it is it's telling the application to wait for Firebase to return the data. If we didn't have that, it would just run this user equals result.user. But it doesn't know what result is. That doesn't exist yet until Firebase has returned information. So that's why we have to use these promises so we can actually get the data and not have our application crash. Here's the config file that I was talking about. So this is 2017. So you can see the rotors engaged, rotor points. And here's this year. You can see total ownership points. So you can see the file really looks the same, except the names have changed. And that's the beauty of this config file. So yeah, it's really the beauty of the config file is that you can just change a few things that you need to change, and it changes it everywhere. So it's not like you don't need to go into all these files here and change everything. You only need to change it here. So then going back, there we go. Sorry about that. So here's the again, here's the application. So I'm going to kind of be going. I'm going to go into like team details. So I'm just going to again select a random team. So this is where we're actually getting the information. And a great thing was Chrome development tools. So if you just right-click on any application in Chrome or any website, I mean, you can go down to inspect. So you can actually see the HTML page. So if I go in deep enough, you'll see these graphs are made using a thing called data tables. So that allows us to make these really nice looking graphs that you see. That, like, as Connor showed you can zoom in and you can select different things. And then you can go into sources. So this is where you can actually see all of our JavaScript files. So these are some just like random things. So I actually made a breakpoint here. So pretty much what that does is that if I refresh the page, it'll actually like stop here and I can see the variables that are inside of that, though I don't think I'm on the right page? Oh, no, I am. Okay. So if I refresh this, well, it should have paused. It looks looking like it's having a little bit of issues. But what it will do is that it will actually stop here on this breakpoint, and you will be able to kind of go, like, highlight a variable. I don't know why it's not loading. It looks like it's just there we go. Yeah, I just didn't select a team. Sorry. So you can keep going through. So you can step over the function. So you can keep going down. Or you can actually step into it, which I'm going to do. Oh, wait. No, I didn't want to do that. Sorry. So pretty much you can just kind of go here. You can see what the variables are storing. So yeah, that's a very helpful thing when we're going through the development of the actual application. So yeah, that's extremely helpful because sometimes we were getting back like this undefined variable, but it made no sense to us because we defined it inside the application. But that's when we learned about promises. It's that it wasn't actually getting any information back. So yeah, I'm going to go back to the PowerPoint. And so now Wade's going to talk about the deep learning part of it. So yeah.
Thank you. Just worked a second ago.
Technical difficulties.
Oh, wait. All right, there we go. Okay, good. Sweet. Okay. All right, good. All right, so I'm Wade. I'm doing the deep learning and fast AI work that we've done on the scouting app. Okay, finally, it's up now. Okay. So really, our whole goal of doing this year was really just to kind of experiment and see kind of what we can do. If we had more time to actually work on this stuff, there's so much more we could have done. But really, kind of what I'm going to go over is kind of just basics of deep learning. What is it? How does it work? And how to apply that with like scouting data and with Blue Alliance data to get results. Yeah. So okay. So what is deep learning? Basically, it's having a machine structure algorithms using layers to make predictions automatically. It's a subfield of machine learning, which is where you are picking the algorithm yourself. And how it works is basically majority of the work, and I'll show it in a second, is just organizing your data. A lot of that is cleaning up, I guess, redundant information that is just going to make your predictions more or less accurate, slowing down your algorithms when they're running and that sort of thing, and just kind of getting it ready to go through these algorithms. That takes up, I'd say, like 80% of the work or 80% of like the time doing this stuff. And then the layers, I'll kind of briefly explain this too. So I guess, here we go. Not touching this. Okay, so pretty much how it works is you have your input layers, and then you have a series of hidden layers where basically what happens is these algorithms are giving random values, like random filters, I guess, that are kind of processed through these different layers, and it's kind of looking for patterns, basically. So like for an example, like if you were looking at like predicting images, also that's called unstructured learning. If you're predicting images, it basically look at all these images, put like a filter over it, and maybe it's like maybe in that filter it's looking at like edges or like eyes or something like that. And it's kind of figuring out like similarities in like in the pictures you're feeding in, for example. And then as it's going through and being processed through these hidden layers, you eventually get your output layer, which is your prediction. And then your loss, so loss is basically how accurate or how close your predictions are to the actual values. So the whole point of going through all this stuff is to basically get your loss to be as close as you can to 0. Then 0 would be 100% accurate. You're spot on with your predictions. And I'll actually show that in a second. Also another thing, so unstructured versus structured learning. So like looking at an image, for example, would be like unstructured learning, and structured learning is like having everything in like columns like by like type or whatever, like with scouting data. So this would be a structured learning problem that we're going through here. And then in this work too, we use the fast AI libraries. I'll talk about that a bit, but super helpful for, I mean, basically like almost like a necessity for doing all this stuff for how it was set up here. PyTorch for doing all of the deep learning processing. It's done in Python. And then Jupyter for basically coding. We code the whole thing in Jupyter Notebooks, and I'll get into that in a second here too. But those three, super helpful and super integral to doing all this stuff too. So this is what so I'll start in the one on the left here. So on the left is a graph of loss. So, and I'll talk about learning rates here too. So like I said before, the whole point of this is to get your loss to be as low as you can. And this is basically done through, well, part of deep learning is choosing your learning rate, and that's going to affect your loss as you're going through your data as it's learning. So the graph on the left is basically looking at, so that curve right there is your loss curve. You want to try to get that to be at the minima of that curve. And basically each one of those steps in that red line is a step going through the data. And the size of those steps is chosen by your learning rate, which is basically another variable that you add, that you multiply your machine learning algorithm with to basically speed it up. So you want to find the right size learning rate so that you reach that local minimum in that curve as soon as you can and with the least amount of steps. So the nice thing with scouting data is it's not a ton of data, and it's not like looking at an image where you have tons of pixels, or like looking at hundreds of images, for example. That would take a much longer time, and it'd be much more important to get that learning rate right. Whereas in this case, it's not really an issue for, I guess, speeding up the process, but really just kind of getting more accurate results. So that's kind of what that looks like, and I'll kind of briefly cover all this stuff too. And then the graph on the right here is just a 3D graph of basically that 2D graph. I'll get into cyclical learning rates a little bit. This is just really a different way of calculating your learning rates. And yeah, so I'll get into that in a second here, or once I get into the Jupyter Notebooks. And then deep learning and FRC, why do it? It's cool. There's a lot of applications for it. Again, we're just kind of doing this to experiment and just see what's possible. For scouting, it's super nice, but again, we don't have a ton of data, so it's hard to make really accurate predictions. So that's really the big challenge, is dealing with a small data set. It lets you predict the future of teams that you've never seen before. So one thing that's been super nice with it this year is that, and this is our first year doing it too, is a lot of the teams in our division that we're competing with, we've never seen before, or maybe we've seen a few matches with, and we don't really know too much about these teams, or we don't have any scouting data collected on these teams too. And like Connor and Blake talked about too, that scouting data really tells you the team specific data, not like what the Blue Alliance gives you, which is more like how the Alliance is performing in each one of their matches throughout the regional. Or throughout their regionals. So it just gives you more accurate results, and we don't have that for those teams. So this is nice to basically predict what that scouting data would be for those teams, which I'll show in a second, and gives you a much better idea of how those teams are going to perform, so that when you're talking to them before a match, you can more accurately and more, I guess, reliably make predictions on how that match is going to go. And yeah, so super helpful for that. And allows you to also find robot statistics that may have been unimportant, or might have seemed unimportant, or not as important as other attributes on a per robot on the surface level, that actually end up greatly affecting match outcome in the long run. So one thing we talked about earlier, one thing that Connor talked about was scale, and how that's the key robot attribute that you really want to have on your alliance if you want to win the match. It's a lot more important than maybe having a double climb or having a triple climb. And some of this stuff is also kind of evident too, just by watching matches. So that's kind of just a basic example of it. But you're looking at the raw data of what all these robots are doing in matches, not just subjective. I think this looks like it's more important because that's just what I saw. This is giving you raw facts. It basically allows you to factually back up your opinion, I guess, on what you think is important, and not just saying, yeah, I think this is important because I saw this match and this looked like it was important. Better decision making in match strategy and alliance selection. So with that match intelligence screen, we didn't have time to implement it this year, but that's something that we'll also take into account when we're going through our matches on Thursday and Friday, is looking at those individual predicted attributes for those robots that we don't have scouting data for, and using that to basically decide our strategy for the matches that we have on Thursday and Friday. That's super helpful to have coming from a drive coaching perspective, and not just kind of guessing or assuming that this team is probably really good at the scale, they're probably going to do this too, and instead having a pretty solid guess on what they're actually going to be doing in the match so that you can, directly, I guess, influence your strategy based off of that. And then possibilities for more complex and advanced robot autonomous capabilities. This isn't related to scouting, but just another example of what you can do with deep learning, like learning what a cube looks like, I guess, or what other robots look like, and how they're traveling around the field and how that affects, I guess, like what they're going to do next, and basically having your robot more autonomously controlled in teleop, and just having less human interaction, just to make it better performing. That's just another example of it. But like I said, the possibilities are endless. Yeah. But again, for scouting, ignore that. Okay. So I will show you how this is all put together. Okay. So I use Jupyter Notebooks to put this together. This is all done in Python. Super nice, very easy to use. So I'm going to go through basically how we got the data and prepared it, and then actually implementing deep learning and looking at results. And I'll run this all to live so you can see how easy this is also. Another thing is, since we have few data for FRC compared to like looking at a bunch of images, we can actually run this all like on a CPU, all on the laptop, where it'd be a lot different. You'd probably want like a couple graphics cards if you wanted to like look at images and that sort of thing. So it's much less intensive on your machine. So I can just run it right here, and it will process everything in a few seconds. Okay. Okay, so like I said earlier, the biggest thing that takes the most time is just getting the data, organizing it so that it's ready for deep learning, and then actually doing the deep learning. That's, I'll show you in a second, but that's much fewer lines of code than this. So we pull from the Blue Alliance and also our scouting data. So first we start out, and I'll just kind of briefly go through this. I won't focus too much on any specific part. But first we pull from the Blue Alliance, so we're pulling everything from all of this year. We're pulling all of the events and all of the matches for each team, just all of the teams. So we're getting everything, basically just setting it up so it's in a more readable format for deep learning, and just so that it makes more sense too for that, so that when we look at it, we can actually tell what's going on. Because I don't know how familiar you guys are with the Blue Alliance API, but when you pull, or I guess let me rephrase that. They give you a lot of data to look at, and a lot of it can be redundant or just not very useful for what we're doing for for deep learning. So we're trying to also get rid of a lot of that data too, and just kind of mitigate that redundant information that might make our predictions less accurate or might slow down us running these algorithms. So this is mostly just getting all this stuff, setting it up in data tables. And then also, like I said before, preparing it for deep learning. So what we're doing is taking Blue Alliance data and taking scouting data and merging it into one CSV file. And these are the file types that we read for this stuff. So if I scroll down a bit more here, some of these graphs are just kind of looking at what the CSV file currently looks like, so that we can get an idea of what we're working with and what else we have to do to change it so that we're like happy with what we have. So some of this stuff is also just making some of the Blue Alliance data just make more sense, like I said before. Scroll down a bit here. And also, a lot of this stuff is going to be on our GitHub too. So since I won't have a chance to go over all this stuff in depth, if you want to look at it yourself, we will be putting a lot of this stuff on our GitHub after the presentation's over. Okay, so we get all the event data, we get all the team data here, and again, that's downloading all the data from the Blue Alliance. And also what we do is every time a match is played, or just throughout the day periodically, we can run this notebook, and it's going to generate a new CSV, new completely updated CSV for the current matches at that current time. So if you ever want to update the CSV so that it's more accurate, it's giving you like the most recent qualification matches, like in Houston, for example. You can just run this. It takes like a couple minutes to run through everything, and then you have a brand new CSV that you can just plug into your deep learning application, and then it already will start using that new data. So super easy to use in that sense. So after we get all the Blue Alliance data, like I said before, we get all the scouting reports for that year, and that's the data that we really care about, and also the data that we're trying to predict too, and I'll get to that in a second. And we're using the scouting data more so over the Blue Alliance data for making our predictions, because like I said too, and like Blake and Connor mentioned also, that's what's giving us those robot team specific values that we don't get with Blue Alliance data. Yeah, so we're getting all this stuff from RoboRecon. It's pretty similar to how we're getting the files in the scouting app too. Won't get too into that though, and then just doing some more pre-processing, preparing it for deep learning, and cleaning it up, just getting it ready to do deep learning on. Also, I'll talk a little bit about what rolling mean is. So one thing that we noticed this year, and especially this applies really heavily to the earlier regionals when people are just trying to, where like the biggest challenge is really just getting your robot working and not necessarily like executing your like most perfect strategy, I guess, in a match, is the matches that matter the most for looking at how capable a robot is at like playing the game, at least at the end of like the day right before alliance selections, is really looking at those last few matches. Once the robot's working, once they're used to playing on the actual field, playing with real teams. So what we do is we added a rolling mean to basically make, I guess, like look at chunks of the robot performing throughout competition. And this isn't necessarily those last 3 matches, but this is just basically sets of groups of matches that takes their current match and then the last 2 and then does an average of that. And that basically makes your data a little bit more accurate, just because you don't need to be looking at 11 matches where you might have one where for some reason they got their sim motors unplugged for half their drivetrain or something, so it kind of skews the data in that sense, which has happened to us. So it just kind of gets rid of some of that confusion. It just makes it a bit more easy to read and also just more accurate too. So there's that. So again, just adding all of that rolling mean to all those different values. And let's see here, some more data tables, just kind of looking at what that CSV file currently looks like as of now. So you can see the different values we have here, different columns, different basically traits that we're looking at. Also another thing too, and I guess I'll mention this now, is one thing we also put in here to just get rid of any confusion and just kind of make this easier to look at from like a scouting perspective, is we've grouped certain attributes and certain robot skills together. So instead of having, I guess, like amount of cubes placed on the scale, we have ability to do scale teleop, for example. So a higher ability to do scale teleop is better than having a low ability to do scale teleop. This is really to encompass different values that we have when we're scouting. So that's like the amount you put on the scale, amount you've missed, efficiency, robot mobility, and so on. Combining those into one stat that we think accurately represents that robot's ability to do that task. And that is really just to make it easier to look at, and also not have like 20 different variables you're trying to predict and only have like 6, for example. Yeah, so that's what that is. And then, so after that, we're just further cleaning this up, and then we're just saving it and exporting it to a CSV. Okay, I don't know how I'm doing on time right now. Okay, actually, I gotta hurry up here. All right, so I'll quickly go over really in depth of how easy it is to basically run a deep learning algorithm on your data just on one stat, and then I'll quickly go over what it looks like to predict all 6 of those robot ability stats too. Okay, so first we're importing all of our stuff here. We're getting those fast AI libraries. That's what we're doing all of our deep learning on. NumPy for all of the math involved. It's another Python library. And then also matplotlib for showing a lot of the graphs here in a second. And it's nice in Jupyter Notebook. You can have your code sectioned off in different sections. And it's just, for reading it and kind of like displaying it, it's like really nice to have. So, I mean, you can see why we use this for this kind of stuff. It's also just nice to present too. So I'm actually running this all live right now. So this is getting that CSV file that we pre-processed before in that other big notebook. And we are basically just doing some further setting up here so that we can run our deep learning model on this. And ignore some of this commented out stuff. That's just me testing some stuff out. Okay, so here is just an example of what that CSV file currently looks like. So this .head is just giving us the first 5 rows for Team 2102. That's us in the CSV file. So this is currently what it looks like with the different scores in here for the different abilities, just so we can see what we're working with. That's super important to have to know exactly what what each column is saying and kind of how it's structured. cause you much less headaches in the future when you're working with this. So that's something I'll constantly be putting in, as you can see as we run through this. So right here, we are selecting what stats we want to use. So like I said before, a lot of the blue alliance data and scouting data crosses over. We don't need, you know, a lot of the averages or like total alliance scores for some of the blue alliance data, and then likewise for some of the scouting data too. So I've commented out some of the statistics they give us just so we have less stuff, makes our model more accurate. And this is also the kind of thing too where you can comment stuff out or add stuff in really easily into these arrays and just kind of see how that affects your accuracy and your predictions. So I have this stuff commented out here, but again, I could mess with this a bunch and add stuff in and try new things out just to see what happens with my accuracy. So it's super flexible in that sense. Then I have the same down here, so I'm picking relevant scouting data that's relevant to predicting what we want to predict, which in this case is going to be our, so in this case it's just predicting one of those values, which is scoring cubes on the scale. And right here we're also just setting up those columns, just basically making them one big thing. Also, I forgot to mention too, so categorical variables are like maybe match number or date and that sort of thing. Not necessarily like numbers that like, I guess, I'm trying to think of the word here, like relate to each other. They're just like, yeah. So continuous variables are like cubes put on the scale, or number of switch cubes missed, or values like that, I guess, or autonomous points scored in the match, or autonomous like scale points made. So that's the difference between two of those. So that's how these two arrays are sectioned off, and we have one for RoboRecon data and one for Blue Alliance data. We combine those two down here. We're cleaning our data up a bit further, so we're making all of those variables just again ready for machine learning. We're also making a copy of our training data set, which is that data set that we just pulled or that we just made in that CSV file. We're making a copy of that just so we can mess with it and not have that original one toyed with, I guess, and keep that one untouched. So that's what we're doing here. Doing some more cleaning up, making all of our continuous variables floating point values. I'm gonna run through this actually, I totally forgot to. So super easy to run through. So I'm actually just gonna run through this right now. So I'm executing all this stuff live. Let me see here. Okay, so this is giving us the length of the training and validation indexes. Also, forgot to mention too, so how the data is basically partitioned is we have our training data set, our validation data set, and our test data set. So that training data set is going to be a certain percentage of that CSV file that we imported, and that validation set is going to be another partition of that CSV file that we're basically looking at our training set data that we've trained the model on and trying to predict values for that validation set, validating our guesses. And then our test set, in this case, would be trying to predict the robot attributes for Houston robots that we haven't seen before. So that's what we're testing this stuff on. Okay, so I'm going to keep running this here. Getting closer. Setting some more stuff up here. Okay, so now it's pretty much ready to go. Also forgot to mention too, sorry, but embedding, this is one thing we have to do with the categorical values, is basically giving them numerical values that mean something. So match number is like independent, each match number is independent of the other one, but like we want to basically figure out what each match number means in relation to each other, or if there is a relation. So what we're doing in embedding is basically turning, for example, is the winner of the match or attempted scale, like yes or no values, do those mean anything, and basically turning those into numerical values. And then after that, we'll use those for deep learning. Okay, so finally we are at the deep learning step. And like I said too, it is very few lines of code to do this. So here we're getting our model. We'll run this guy here. And then we are going to basically run it and see what it spits out. So I'm going to run it here. We have our learning rates set here. Again, this is something that for like cyclical learning rates that I mentioned earlier, basically what it does is it kind of ramps up the learning rates each time You run through an epoch, which is basically just a full run through of your data, or not a full run through of your data, but a full run through of your cycles, and one cycle is a full run through of your data. So let me see here. I'm kind of trying to speed up here. So we got that, did one epoch, and then this is a graph of our loss function. So as you can see, it's going down as our learning rate's increasing, but it would start going up as if we kept increasing our learning rate. And I'll keep running this guy, so it's gonna run it again. So again, like I said too, this loss function is basically your error. You want that to be lower for your training and validation, of course. I'm gonna keep running this. So we're gonna let this go here, and as you can see, it's getting better as we're running, so that those values, those loss values are getting lower, which is good. And eventually it'll start kind of plateauing out. So like right here, it's stopping around 1.1 for validation, and for training, it's still going down a bit, but plateauing around 0.9. Keep running this guy. And so yeah, so we're gonna basically predict those values, and this is just a really simple, basically just representation of like how close we are. Like I said too, it's hard to be really accurate with this stuff. We don't have a ton of data, and again, this is something that we were just kind of doing this year to experiment. So some of the stuff actually is pretty close. So we have our actual values and our predicted values. So we predicted that one, that's pretty close. 2 and 4, that's a little bit off. 3, that's also pretty close. So it's not too far off. So even with just this few amount of data, it's still not too bad. Definitely could be better, but as you can see, for like some of these, it's getting pretty close. 4 and 2, okay, that's a little bit off. Like 3 and 5, that's also a little bit off too. But yeah, so you kind of get the idea with it's very little amount of code to kind of get this to work. And again, if we had more time, we'd make this in a much more like visually appealing format. I'll actually run through the multi-label really quickly here. We're just doing a few different things to basically take into account the different things we're trying to predict. So in that last one, we were just predicting one thing, but for this one, we're predicting all 6 of those ability to do whatever in a match. So I'll really quickly go over this stuff too, just because I think we're running out of time. But right here, we're again setting up the data, getting it ready for doing multi-label classification. Again, we have graphs right here, so we have our loss and our learning rate. So at a certain point, the loss starts to increase as we increase our learning rate. Yeah.
Can you actually give an example of how you use all this stuff for your scouting? As you're getting ready for your lines getting ready to go out there, how do you strategize with using this information?
Yeah, sure. So after we get this information, we'd also run this before every single match and basically put this into our CSV file that we're using for our current scouting data for Houston, and we'd look at that match intelligence screen with this data that we are predicting here, and using that to determine what we want to do for that match. So we basically just use that data with the current scouting data, and also compare the two to make this data more accurate in the future when we compile it again. So yeah. Okay, I think it's 3 right now, so I think I'll stop this here. And if you guys have any questions, we can do a really quick Q&A if there's any questions. Yeah, one in the back.
Is there a solution for not get connection and you can still get the scouting offline?
Okay, so the question was offline scouting. If you can't have a connection, can you, I guess, use the scouting app if you don't have any connection? Do you want to answer that, Connor?
So if you're using the application offline, then as soon as you connect back online, then it'll actually update the application with all that data that you inputted. So yes, that's the best solution that we're able to come up with. I mean, usually in most competitions, we haven't run into any issues with like a loss of connection, because usually you can just use mobile data, because remember, Wi-Fi hotspots are a big no-no at first events. So yeah, that's the solution that we came up with.
Where you storing the data until it gets uploaded?
So that data is all still stored on, before it gets uploaded, I'm assuming actually you guys would probably be more fit to answer that.
So
but it's
are you
stored
asking
locally
like where
at
is
that
the
point.
data stored when it's running offline?
Yeah.
So it's stored like on your phone. It's like cache data with Chrome, and the second you and Firebase allows you to work when you're kind of like offline. It's still storing it on your phone. It's trying to send it to Firebase, and it'll continue to try to send it until you get a connection, and then it will boost it all up to Firebase when it gets that chance. That's again like working with those promises. It's saying I'm going to keep waiting until I actually can submit this.
If you're sitting here scouting 10 matches and qualifying matches,
It's just stored locally on
Yeah,
your
it's
device, so
just
once you reconnect,
just
it'll-
data. It's just kind of like stored cache data on your phone. If like you're running Chrome, you can actually see like what the data you have cached, and then it will push it all up and it will delete it when it's done.
Yeah. So yeah.
So someone, I can't remember who stated that this application is really flexible based on what device you're using, and you mentioned using it on tablets. Have you ever had any trouble compiling the data when it's coming from different types of devices?
So the. Yeah, there's no issue with that. It's really because it doesn't matter. It doesn't care where the data came from. It's still all stored in 0 or 1 for like no. Did they park? No, they didn't. Did they park? Yes, they did. Or how many cubes they get? It's all stored. It's just sending. It doesn't care what device it was sent from. All it cares about is the actual data itself. And since we're using like HTML, it's very nice to go from like going from a computer to a phone. Like you can actually do it with the Chrome development tools. I don't know if you want to do that.
So no, there is no.
Yeah, there's no
issues.
issue.
Yep. Okay.
Have you used Sql, the Sql library for deep learning, or you?
I have not used it before. No. I mean, yeah. What's that?
The other one was, why would you use an SQL-based database for your application? Is it for the Firebase features, or because SQL is not, not used?
So your question was why use an SQL database for scouting? You guys want to answer that?
We're not actually, so we're using a NoSQL database so we can have the live updating, and it's one less thing we have to learn. So Firebase is actually really easy to get the information. It stores the data in these things called nodes, and so what that is it's pretty much you have a base URL for the Firebase application, and it's pretty much like using any website. If you do like slash, take slash whatever you want to go to, so it keeps going deeper into the website. So it works the same for Firebase. You do slash, I want to get the events, so you do slash events. And it takes you to that data. So it's actually way easier to use instead of a SQL.
Yep.
What are all the platforms that deep learning is compatible with?
What do you mean by platforms?
So say for instance, if I was like, you guys are using Python. Say for instance, if I was writing all of my code in R, but I still use the deep learning.
So we're doing all this in Python, so there's other libraries for other programming languages, I guess if that's what you mean. But we're just doing this all in Python. But again, if you could totally do this in a different programming language. But there are a lot of Python libraries, and Python is like one of the big languages for doing deep learning and machine learning. So there's a lot more support for it, I guess, which is why we do it. Yeah. Yeah. Points per time scored. So like with the power-ups and that sort of thing?
So,
Trying to think. Sorry, could you repeat the question? Right. Sure. Do you guys want to?
So, with the time scoring, when we were looking at that initially, we realized that it would actually be quite difficult for scouters using the application to adequately assess or log how long a certain alliance had ownership of the scale. So it was essentially a compromise, and we found that the best way to actually log the performance would just simply be to log the amount of cubes that they would place on the scalar switch. So the answer is no, because one, it would be too difficult for our scouters to measure adequately. And we found that the way that we have it set up is still very useful.
All right, so I'm going to do, sorry, we have time for one more question. Yeah.
can you say that one more time? Oh, like on the actual website, we're using a extension called data tables. So it allows you to make these extremely nice, like the graphs that you saw or the bar graphs. So we use data tables. We just pass the information to, they have a lot of documentation online on how to make the graphs look nice.
Yeah.
Any other JS libraries that point out to the front end of that?
Not that I can really think of off top of my head.
All
but
this stuff is going to be on our GitHub too, so.
High charts. We also use that for some of the graphing.
Okay, so we're just out of time. We're actually going to be out there if you guys have any more questions. The next group is ready to come in. Thank you so much for coming. Thank you. And yeah, all this stuff will be on our GitHub.